Welcome back, 8th grade. I hope you had a very good Easter break. I hope you took time to really think and consider about Easter, what it stands for, and what it means for us as Christians. Well, we are back in Earth Science, and we are in chapter 16. And the title of this chapter is Mountains and High Hills. And so today we're going to take a little bit to think about describing mountains. What is the definition of a mountain? Have you ever heard that phrase, don't make a mountain out of a molehill? Well, that phrase is supposed to mean don't make a big deal out of something that's really a small deal. But if somebody asked you, could you tell them the difference between a mountain and a molehill in terms of size? Well, if you did, you would probably have to start to define the word elevation. That can become a little bit difficult when you're asked to define the difference between a mountain and a hill. You can define a mountain as your book puts it on page 413, a natural elevation of the Earth's surface rising more or less abruptly to a summit. A summit would be the very tip or top of that mountain. Now, I want to share my screen with you because I want to show you a few things to help you think about this. So let's look at the differences between hills and mountains. So one way to think about it is like this. On the left side of your screen here, you see a hill. We can say that is a natural mound of earth created by either faulting or erosion. You could think of it as a bump in the landscape, a lower altitude and elevation with a rounded top. It's often unnamed. We don't name every hill. Now let's think about a mountain. A mountain is a natural mound of earth created by faulting. That means when plates push together. A steep rise in the landscape. It has higher altitude and elevation with a defined summit or peak. And often we name mountains. Now, when we think about mountains, we need to think about the difference between elevation and height. An important characteristic of a mountain is its height. Where do we begin to measure height? For example, the highest mountain on Earth's surface is Mount Everest. It's at 29,028 feet. You've probably heard a lot about Mount Everest. Let's take a look at a picture I want to show you. Okay, so here's an example. All right, let's see here. Let's take a look at Mount Everest. All right. Here, I'll include that bottom part here. Mount Everest. Okay. So, almost everyone calls Mount Everest the highest mountain in the world. I'm going to zoom in a little bit. And climbers from everywhere travel to Everest hoping to earn the distinction of climbing the world's highest. But what does world's highest really mean? Mount Everest is called the world's highest mountain because it has the highest elevation above sea level. That's an important point. It has the highest elevation above sea level. We could also say it has the highest altitude. The peak of Mount Everest is 8,850 meters, or 29,035 feet, above sea level. No other mountain on Earth has a higher altitude. However, some mountains might be considered taller, with taller being the total vertical distance between their base and their summit. All right, so let's look at this mountain. Well, for instance, that is Mount Everest right there, but it's Mount Everest as seen from Gokyo-ri. Now let's look at Mauna Kea. Is it the tallest mountain? Well, Mauna Kea has an altitude of 4,205 meters. That's 13,796 feet. Well, that's much lower than Mount Everest. However, Mauna Kea is an island, and if the distance from the bottom of the nearby Pacific Ocean floor to the peak of the island is measured, then Mauna Kea is taller than Mount Everest. Mauna Kea is over 10,000 meters tall compared to 8,850 for Mount Everest, making it the world's tallest mountain. Well, let's look at a different one. Let's look at Chimborazo, highest above the Earth's center. Let me zoom out just a little bit here where you can see. Okay. Chimborazo in Ecuador has an altitude of 6,310 meters. That's 20,703 feet. Mount Everest has a higher altitude, and Mauna Kea is taller. However, Chimborazo has the distinction of being the highest mountain above Earth's center. This is because the Earth is not a sphere. It's an oblate spheroid. As an oblate spheroid, Earth's widest at its equator. Chimborazo is just 1 degree south of the equator, and at that location, it's 6,384 kilometers, or 3,967 miles, above Earth's center, or about 1.2 miles farther from Earth's center than Mount Everest. All right, so the question becomes, well, which one's the tallest mountain? Well, which one's the tallest mountain depends on how you define tallest mountain. So we want to know the difference between the elevation and its actual height based on the sea level or from the sea floor. Now, another thing we want to look at is when we have maps, we're used to reading maps to know which direction we should go. Well, what about how we read a map that shows us elevation? Maps that show us elevation are called topographic maps, or sometimes they're called relief maps. So I want us to take a look at what those are, because you need to be able to read one. So how to read a topographic map. Topographic maps are a little different from your average map. Not only do they show the location of things like roads and trails, but once you get the hang of reading them, they also help you visualize three-dimensional terrain from a flat piece of paper. Topo maps use 3 main mechanisms to describe the terrain. In this video, we're going to cover how to read the map's contour line, how do you understand scale, and how to read the symbols and colors found in map legends. Contour lines are what really make topographic maps something special. These lines connect all the points on the map that share the same elevation. By looking at how the contour lines spread out and come together, you can get a good sense of what the terrain looks like when the lines are packed close together. That tells you that the elevation is changing a lot in short distance, so the terrain is quite steep as the lines spread out. The elevation changes more slowly, so the slope is more mellow. Contour lines can also help you visualize the shape of the terrain. For example, as the lines form smaller and smaller circles, they're probably showing a peak. Spend some time with a map of a familiar area and see if you can pick out terrain features just by looking at the contour lines. Every 5th contour line on a topo map is thicker than the other lines, and those thick lines are called index lines. At some point along every index line, you'll find the elevation for that line written on the map. The change in elevation from one contour line to the next is always the same on the map, and most maps have either a 40 or 80-foot contour interval. If your map has an 80-foot interval, that means that each contour line is 80 vertical feet away from the next. You can find all the specific details about the contour intervals and index lines for your map in its legend. Scale refers to the relative distance of the map. For instance, this map is a 1 to 12,000. That means that 1 inch on the map represents 12,000 inches in reality. Another map of the same region is 1 to 50,000 and covers a larger area, but in less detail. The important thing is that the map with a smaller scale will show a smaller area, but with more detail. Understanding the level of detail on your map is handy when planning your route, but it isn't much help if you want to calculate distances efficiently. That's why maps also have a small representative scale near their legend. This scale shows you the relative distance of a mile or a kilometer on your map, and you can use the edge of a compass or even a piece of string to help figure out just how far away that peak is. One of the first things to look for on any new map is the legend. The legend is like the user's guide for your map. It's where the various line colors and symbols are defined. When it comes to colors on the map, the idea is that the darker the color, the denser the vegetation. As you get closer to the top of a peak, you'll notice that the colors get lighter as the forest spins out, and of course, streams and lakes are represented in blue. Alongside the list of symbols, there are a few other important pieces of information like details about the contour lines and the date of the maps, most recent revisions. This is also where you'll find the magnetic declination for the region, which we'll use to set up your compass. When you combine your understanding of contour line scale and your map symbols and colors, you can almost visualize your whole trip before you go to the next step. All right. Well, that's relief maps and how they work. Okay, so let me go back to full screen. All right, guys, so I hope you've been following along. I started on page 413. We described mountains. We talked about the difference between elevation and height, and we looked at some particular mountains and then thought about, well, which is really the tallest mountain, and found that it depends on how you define its height. All right, and then we talked about relief maps, what they are and how they're used. Now, I want you to do a little bit of research. I want you to look up a person named Sir Edmund Hillary. Let me go back to share this screen just so I can show you his picture here. Sir Edmund Hillary. Now, he was very famous for something having to do with mountains. All right, he was the first person to do something, but I want you to find out what. So, do a little research on Sir Edmund Hillary, Sir, S-I-R, Edmund, E-D-M-U-N-D, Hillary, H-I-L-L-A-R-Y, Sir Edmund Hillary. And on your exit slip, there's going to be a paragraph answer where I want you to tell me in just a few sentences, who was he and what did he do that made him famous? Okay, so Sir Edmund Hillary. That's going to be part of your exit slip today, so go ahead and do some research on that. You can look on Britannica.com. That's a good place. Wikipedia will have information about him too, but Britannica.com has a biography section where you can look up Sir Edmund Hillary. So read that, figure out who he was and what he did, and then be ready to do your exit slip. Remember, guys, if you have any questions about what you see in Google Classroom, feel free to email me, and I'll get back with you, and I will talk to you guys later.